Okay, hi everyone. This is the fourth video of my maths homework. So let's do this question first. In an increasing GP, the sum of the first and the last term is 66, and the product of the second and last but one term is 128, and the sum of all the terms is 126. Okay, how many terms are there in the progression? So we are going to use the formula that the sum of n terms is going to be it's going to be LR minus A upon R minus 1. Well, how do you derive this formula? You just use the fact that 8 times R to the n minus 1 upon R minus 1, which is obviously the sum of n terms. This can be written as A times R to the n minus 1 times R minus A upon R minus 1, and this thing is nothing but L, which is the last term. So this is nothing but LR minus A upon R minus 1. So that's the way you can derive this formula. So we are going to use this. So we already are given that the sum of all the terms is 126, and we are given that the product of the second and last but one term is 128. So the second term is going to be A times R, and the last but one term is when you divide L by R, right? Because the last term is obviously the last but one term times this ratio. So the last but one term is this last term upon the ratio, right? I mean, that's obvious. So this is going to be the last term divided by the ratio, and you can see these cancel away, so you just get A times L, and this is going to be equal to 28. No, the product of the second and last but one term is 128. Okay, so it's going to be 128. So we can put this inside this equation, that L times A is going to be equal to 128. So hopefully we'll be able to find some relation between A and R easily. So that's nice. So what I'm going to do is that I'm going to multiply this equation by an A. So I will get L times A times R minus A squared upon R minus 1 equals to 126. Okay, now L times A is going to be 128, so 128 R minus A squared upon R minus 1 is going to be 126. Okay, that's a nice equation. So two statements are already done. Let's move to the last statement, which says that the sum of the first and the last term is 66. So you have A plus L is equals to 66, and basically you also have A times L equals to 128 from the other statement. All right, so in fact you don't even need to actually use this, because you can directly get the value of A and L from these two equations itself. Okay, so that's nice. So we will just use this when we want to find the value of R. Just to minimize this. Yep. Okay, so we will be using these two equations first. What I'm going to do is that I'm going to multiply this equation by L, or maybe I should multiply this by A. So I will get A squared plus AL equals to 66A. Now I can input the value of AL over here. So A squared plus 128 is equals to 66A, which means that A squared minus 66A plus 128 is equals to 0. So now we want to factorize 128 into two numbers which can add up to 66. 128 is nothing but 2 to the 7th power, right, which is 32 and 34. No, that won't work. 128 is 64 times 2. Oh, that will work. So 128 is 64 times 2. So this 66 can be written as 64 plus 2. That's nice. So just erase this now. So from this you get that A minus 64 and then A minus 2. This is equal to 0. So A equals to 2 or A equals to 64. Okay. Now here we are given that the GP is increasing. See, this is an increasing GP. So putting the value of A as 64, you will get the value of L from this equation as 2. which is not correct because this is supposed to be an increasing GP. So in that case the last term should be bigger than the first term. So only a equals to 2 is the correct option. I mean a equals to 2 is the correct statement. So a is equal to 2 and L equals to 64. So now we are almost done. So a equals to 2, L equals to 64. 64. So we can just put this value in this equation to get the value of r directly. So you will get 128 r minus a squared, which is just 4, upon r minus 1 is equals to 126. Alright, let's just erase everything else. So now I can multiply this by r minus 1 to get 128 r minus 4 is equals to 126 r minus 126. Okay, so from this we can say that 2r is equals to 122. So r is supposed to be 61. Wait, really? I think I messed up something, but that's what it is. Okay, this is not looking correct at all. Nope, something is messed up completely. Just do that once again. Alright, so you have 128 minus a square upon r minus 1 equals to 126. So that's going to go there. So it's supposed to be minus 4. You do get 122. You get 2r. Okay, this is like almost correct. I think this is like, okay, whatever. We just do it once again. So what was the other condition which we were given? The product of the first and last term is like 128. Okay, that's correct. Sum of all the terms is 126. How many terms are there in the progression? Okay, so we are going to use the fact that sum of all the terms is 126, which means that L r minus a upon r minus 1, that is supposed to be 126. So oh, now I get it. We were supposed to multiply this equation by a, but we didn't multiply by a on the right hand side. That's why everything got so messed up. Okay, so now instead of just multiplying by a and putting the value of L times a, what I will do is that I will put the value of L and a in this separately. So I will get 126 over here. So L is going to be 126. Sorry, L is going to be 64 r, then minus a. So a is nothing but 2, and this is supposed to be 126. That seems reasonable. So I will say that 64r minus 2 is equals to 126r minus 126. Alright, so hopefully I will be able to get some good values from this. So we are getting 190. No, wait, sorry, I think that's not how it's supposed to be going. Oh, so 16 minus, okay, 6 minus 1 is just 2. 12 minus 6 like 62. 62r is going to be equal to 122. Wait, what? No, 124, sorry. Which means that r is supposed to be 2. That's easy. Okay, so the common ratio is 2. Okay, what are you supposed to find? Yeah, how many terms are there in this progression? So the common ratio is 2. The first term is 2 and the last term is 64. So I will use the fact that 64 is equals to 2 times 2 to the n minus 1 power, where n is the number of terms. So obviously 64 is just 2 to the 6th power, and this is going to be 2 to the nth power, which means that n is equals to 6. So there are 6 terms in this GP. Okay, this was easy. I mean, not too bad. So there are supposed to be 6 terms in this GP. Let's move on to the next question. If the 4th, 7th and 10th term of a GP are PQR respectively, then Q square equals to PR. Okay, so we have to prove that Q square equals to PR. Oh, so we have to prove that. Yeah, they're supposed to be like prove that this statement is true kind of condition, whatever. So if the 4th, 7th and 10th term of a GP are PQ and R. So the fourth term, which is going to be AR cubed, is P. The seventh term, which is going to be AR to the sixth power, that is Q. And the 10th term, which is AR to the ninth power, is R. So like this is A7, this is A10. Now you can clearly see that these PQR are also in a GP, and they have common ratio of R cubed, right? So when you multiply P by R cubed, you get this thing. When you multiply Q by R cubed, you get this thing. So which means that PQR are also in a GP. Therefore, P by Q equals to Q by R will give us PR is equals to Q squared. Easy as that. Okay, so this was very easy to prove, not a big deal at all. The next question is if alpha beta are the roots of the equation x squared minus 4x plus lambda equals to 0, and gamma delta are the roots of the equation x squared minus 64x plus mu equals to 0, and alpha beta gamma delta are given to be an increasing GP. Okay, then find the values of lambda and mu. Okay, so what we are given is that alpha plus beta, which is the sum of the roots, is supposed to be negative coefficient of x upon the coefficient of x square, which in this case turns out to be 4, because this equation has your negative coefficient of x as 4 and the coefficient of x square as 1, so it will be 4 upon 1 is 4. And then similarly gamma plus delta, that's going to be negative of negative 64 upon 1, which is 64. Now we will be using the fact that these are in an AP, these are in a GP, an increasing GP. So from this equation I can say that A plus AR is supposed to be 4. From this equation I can say that R squared plus AR cubed is 64. Now I can divide these two equations. I'm going to divide this equation by this equation, so that will give me, you can clearly see that this is just like this is multiplied by R to get R squared to get into this equation. So I will just get R squared is equals to 64 upon 4, which is 16, which means that R is equals to plus minus 4. But because this is supposed to be an increasing GP, you cannot have alternate positive negative terms, which would make it a weird GP, not an increasing GP throughout. So R is only equal to the positive 4. Okay, that's nice. So let's just erase all this stuff. So now you know that the ratio is going to be plus 4, and you also have the fact that alpha plus beta is equals to 4, which means that alpha plus 4 alpha is equals to 4, which means that alpha equals to 4 upon 5, which implies that beta is equals to 4 times this thing, which is just 16 upon 5. Gamma is 4 times this thing is 64 upon 5, and delta is 4 times this thing, which is 24 to 256, which is 256 upon 5. Okay, that's nice. Let's just check this. Gamma plus delta is going to be equal to 320 upon 5, which is 64. That's correct. So yes, this does work. Okay, and what are we supposed to find the values of lambda and mu. Oh, that's nice. So lambda into mu is going to be the product of alpha beta and the product of gamma delta, because the coefficient of x square is 1. So just erase everything. Okay, so our lambda is going to be equal to, actually lambda upon 1 is equals to alpha times beta, but that 1 doesn't matter, whatever. So alpha beta is going to be this thing times this thing, which is just 64 upon 25, and then mu is going to be equal to gamma times delta, which is 64 by 5 into 256 upon 5. Okay, so 64 into 256 upon 25. Sorry. Okay, so 64 into 256, just need to calculate this now. just do it fast. Okay, so 4 times is like 10240, and then 6 times this thing is going to be 36. 6 3 carried on, 3 carried on 30, you have 3 carried on once again, so 18 and 3 is going to be 2 1. It's supposed to be 2 2 3 8 4 or something like that. There might be mistakes in this, but that seems correct. Yeah, it does. So yeah, that's fine. Okay, let's do this one. So 0 and then 36 3 33 3, and then oops, yeah, there was a mistake in this, as I thought. This is supposed to be 12 and this is supposed to be 15 over there, so it won't be this thing. It will be 16 3 8 4, something like that. Okay, so that's going to be our answer. Our lambda is alright, so our lambda is 64 upon 25, and just write this somewhere. Lambda is going to be 64 upon 25, 64 upon 25, and then this mu thing is going to be this massive number upon 25, 16384 upon 25 is going to be 16384 upon 25. Whatever, let's move to the next question. Sum to n terms of the series, this is 0.7 plus 0.77 plus 0.777. Okay, so yeah, this is a very standard thing to do. This is just 7. Okay, so let's do the A question first. So it's going to be 7 by 10 plus 77 by 100 plus 777 upon 1000, which is nothing but, what's this, 7 upon 9 into 10 minus 1 upon 10 plus 100 minus 1 upon 100. You can just verify what I'm doing right now, right? You can verify if this really is equal to that. So plus 1000 minus 1 upon 1000, and yeah, this is supposed to be going like that. Okay, this keeps on going, which is okay. So this goes on till n terms, and this also goes on till n terms. So this is supposed to be 7 upon 9 into 1 minus 1 by 10 plus 1 minus 1 by 10 squared plus 1 minus 1 by 10 cube, and it goes like that till n terms. Alright, so that's going to be equal to, just erase everything, that's going to be equal to 7 by 9 into, well, how many ones like these are collected, n of them, so n, and then this is a GP with n terms, right? This thing. So the first term is minus 1 by 10, the ratio is obviously 1 by 10, so 1 by 10 to the nth power minus 1 upon 1 by 10 minus 1. Okay, so this simplifies to 7 upon 9 of n, and then multiply the numerator and denominator by 10, you just get minus 1 by 10 to the n minus 1 upon, well, what's this, like minus 9 something. So yeah, I think so, it's supposed to be minus 9, whatever. It's supposed to be 7 by 9 of n, and then you have minus of 10 to the n minus 1 upon 9, but this complete is divided by 10 to the n. So yeah, that's going to be the most simplified version of the answer you can get. So that's nice. Let's do the next question, which is B. Obviously there are no options in this, so we can't verify if it is correct or not. Okay, so B is 6 plus 6, 6 plus 6, 6, 6. It keeps on going like that. So this is nothing but 6 by 9 of 9 plus 9, 9 plus 9, 9, 9, which is nothing but 10 minus 1 plus 100 minus 1 plus 1000 minus 1, and it keeps on going like this till n terms, which is going to be 6 by 9 of, how many minus 1s do you get? Obviously n of them, so it's supposed to be minus n, plus this is a GP with the first term being 10, the ratio is 10, so it's supposed to be 10 to the n minus 1 upon 10 minus 1, which is 9. Yep, so what's this going to be? It's going to be negative 6 by 9 of n plus 10 to the n plus 1, actually 6 times of this thing, upon 81, and then minus 10 upon 9 into 6 upon 9 minus 60 upon 81. Okay, that's nice. It's supposed to multiplication between these two. Okay, so that's the most simplified version of this answer. Let's go to the next question. This is completely just like the previous one, so I don't think that we should even do this. Just multiply by 8 instead of 6. So just do this pretty fast. 8 upon 9 into minus n, because these many of minus 1s, and then plus 10 into 10 to the n minus 1 upon 9. Yep, that's the answer. Easy as that. And you can simplify it further, but you get the idea that all of these are the same basically. Then let's go to this thing. Prove the equality 6 n digits plus 8 n digits. Okay, so this is a square over there, is equals to 4 so on till 2n digits. Okay, this is not too bad to do. So what is this going to be? This is going to be 6 upon 9 of, well, what is this thing? 9 n digits, so 10 to the n minus 1, and then this complete thing is squared, plus what is this thing? This is supposed to be 8 upon 9 of 10 to the n minus 1. Alright, and this is supposed to be equal to 4 till 2n digits, so this is supposed to be 4 upon 9 into 10 to the 2n minus 1. Alright, so that seems cool. What can we do with this? Obviously the first thing which comes to my head is that we can factor this into 10 to the n minus 1 and 10 to the n plus 1. So in that way we can kind of factor out 10 to the n minus 1 from everything and just cancel it away. So that's nice. So what we can do is that we can get this is just 3 upon 2 upon 3, I think. So this is going to be 4 upon 9 into 10 to the n minus 1 squared, but you then take out a 10 to the n minus 1 from that, so you get 10 to the n minus 1 with a single 1 power, plus 8 by 9, and then this 10 to the n minus 1, this thing is gone, is equals to 4 by 9 of 10 to the n plus 1, because you factored it out and you took out a 10 to the n minus 1. Alright, so now you can just cancel these 9s away and also these away, and then this becomes 2. Okay, that's nice. Just erase everything right now. So you get 10 to the n minus 1 plus 2 is equals to 10 to the n plus 1, and which is obviously true because minus 1 plus 2 is just 1, so this thing is obviously equal to this thing, so that's nice. So yep, this is a legit equality and we have proved it. Okay, let's go to the next question, which is the root of, okay, these things is equals to 3. Okay, so is this true or false? You want to see if this equality is true or false. Well, this is going to be true only if you have 2 n digits minus 2 n digits is equals to 3 n digits squared, right? Because just squared both sides. Now we will be using the fact that this thing can be written as 1 by 9 of 10 to the 2n minus 1. This thing can be written as, what's it supposed to be, minus over there, right? Minus 2 by 9 of 10 to the n minus 1. Okay, and this is supposed to be equal to 3 by 9 of 10 to the n minus 1, but this time squared, pretty much like the previous question. So this 3 by 9 can be written as 1 by 3, and then when you just square this, you can see that this is coming out to be this thing squared and then 1 by 9, so this 9, these things cancel away. Then you can cancel out 10 to the n minus 1 from every of these factors, so you just get 10 to the n plus 1 because you factorize this into 10 to the n minus 1 into 10 to the n plus 1 thing, and then you got minus 2 times of nothing, so this is just 1, is equals to 10 to the n minus 1. There's still one of them left, So yep, this is true, right? This is supposed to be 10 to the n minus 1 equals to 10 to the n minus 1, which is obviously a true statement. So yes, this equality is also correct. So this statement is true. Yep, this is true. Let's move on to the next question. Express the recurring decimal 0.125125 as a rational number. Okay, that's nice. So 0.125125, let's call this number as x. Now I know that I should be doing this using a geometric series, but whatever, let's just do it the old way, which is when you multiply this by say 1,000. So you get 1000x is equals to 125.125125, so on, and then you subtract this, you get 999x is equals to 125. Then you get x equals to 125 upon 999. Okay, that's like the old way, and also the easiest way of doing it. And there's also another way which is a bit more complicated, and I don't think it's actually necessary, but because this is supposed to be a GP question, let's just deal it like this. So 125, so on. This is nothing but 125 upon 1000 plus 125 upon 1000, and then once again divided by 1000. So this is supposed to be 1000 to the second power plus 125 upon 1000 to the third power, and it keeps on going like this. So that can be written as, this is supposed to be a GP, and this keeps on going to infinite terms. Alright, obviously the ratio is going to be 1 upon 1000, which is a ratio which is less than 1 and greater than 0. So yep, this GP is going to be equal to 125 into r to the n. But here's the thing, r to the n, what is that supposed to be? This is supposed to be 1 upon 1000 raised to the infinite power, which is 0 minus 1 upon r minus 1, which is just 1 upon 1000 minus 1. Okay, that's nice. So that is equal to 125 upon 1 minus 1 upon 1000. Now what can you do with this? You can obviously multiply both the numerator and denominator by 1000, so you just get 125,000 divided by 999. I think that's correct. Wait, what? No, this is not very correct. Nope, something is wrong. Something is definitely wrong over here, because that's not what we got for that question. Did we get the same thing? No, I don't think so. Nope. Oh yeah, the first term is supposed to be 125 upon 1000, not 125 itself. So this is going to be everything divided by 1000. So instead of having these three zeros, you will just have 125 upon 999, which is completely in agreement with the answer which we got previously by our simpler method. That's nice. What's the second question? Prove that the rational number which equals to the number 2.357 recurring with recurring decimal is 2355 upon 9. Okay, so instead of going for the whole GP thing, this is actually doable just using our old method of letting this being equal to x and then multiplying this by 1000. So 1000x equals to 2357.357 recurring. So then you subtract them, so you get 999x is equals to 2355. So that's nice, x equals to 2355 upon 999, just as we expected. So that's nice, cool. And yes, you can also deal this using the sum of a geometric mean. I mean the sum of an infinite geometric series, but I don't think that's necessary. Okay, so next we have to find the value of 0.123 recurring as a geometric series. Oh, so they want us to write it in terms of a geometric series. Okay, so here we go. So 0.123 recurring is nothing but 0.1232323, which is nothing but 0.1 um 0.1 plus 0.023 plus 0.00023, and it keeps on going, which is the same as saying 1 by 10 plus what's this, 23 upon 1000 plus 23 upon what is this thing, 1 2 3 4 5 upon 10 to the fifth power. I just write this as 10 to the third power as well, which will make more sense, plus 23 upon 10 to the seventh power, because once again you move 2 decimal places back. So this will just keep on going like that. And yes, this is a geometric series, though the first term is not exactly a geometric series, so just discard it, and this thing is going to be a geometric series, so that's nice. Okay, let's move to the next question, which is find the value of 0.423 recurring. Once again, wait, what is this question? Find the value of 0.423. Wait, that is the value of 0.423 recurring. It's just 0.423. Maybe they are telling us to rationalize it, write it as a rational expression, or maybe like write it as a geometric series. So if this is supposed to be geometric series, then you pretty much get the same geometric series which we got in the previous question, just that 0.1 is replaced by 0.4. So your geometric series would look like 4 by 10 plus 23 by 10 cubed plus 23 by 10 to the fifth, and it keeps on going like that for infinite terms. Or if you want to rationalize this, right, write it in terms of a rational expression, they can obviously have x equals to 0.423 recurring, then 100x is equal to, that's going to be equal to 42.323 recurring. Yes, I think so, correct. So you will have 99x is equals to 42.3, which implies that x is equals to 42.3 upon wait, what, 42.3? No, that's not correct. It's not supposed to be like that. 99x is equals to 42.3 minus of this 0.4, which is going to be 41.9. X is equals to 41.9 upon 99. Okay, that's equal to 419 upon 990. So that's a rational expression. So whatever, this is very easy, but the question is not very well defined, so if you don't know what to do with it, just find the value of 0.423, whatever, I mean 0.423 recurring. Okay, this is another question which is of GP. A ball is dropped from a height of 48 feet. So suppose a ball is dropped from a height of 48 feet and it rebounds to 2/3 of the distance it falls. So it rebounds to 2/3 of 48 feet, right? So this becomes this much. If it continues to fall and then rebound once again this way, so the next time it reaches the height of 2/3 squared of 48, and then it keeps going like that. Okay, how far will it travel before coming to rest? Didn't get it. How far will it travel before coming to rest? So what are we supposed to find? Are we supposed to find the distance traveled by or the displacement? I think we are talking about the distance, so that's nice. Okay, so the first time it obviously goes 48 feet, then it goes 2 times of 2/3 of 48, because come on now, try to use logic over here, that once it has completely fall, I mean it has hit the ground, then it goes up to this 2/3 of 48 thing, this length, and then it falls down once again the same distance. So it's going to be 2 times of this thing. That's the complete distance covered by it in this jump whatever, this bounce. Okay, then the next time it goes like 2/3 of that, and then next time the 2/3 of that. This is going to be plus 2 into 2/3 squared of 48, then plus 2 into 2/3 cubed of 48. So you get the idea, and then it keeps going like that for all eternity. Yeah, so what is this going to be? This is going to be 48 plus, what's 2 times of 48? That is obviously just 96 times 2/3 plus 2/3 squared plus 2/3 cubed, I mean 2/3 cubed, and it keeps going like that. So this is supposed to be 48 plus 96 into 2/3 into the ratio is obviously 2/3, so 1, I mean like, okay, 2/3 to the nth power. Well, here n is infinity, minus 1 upon 2/3 minus 1, and this is obviously going to be 0 because something which is less than 1 raised to the infinite power is supposed to be 0. I mean, if that something is not negative, it's between 0 and 1, then that thing raised to the infinite power, that's supposed to be a very small number, so it's almost 0. But this is nothing but 48 plus 96 into, now you multiply by 3 by 2 on the just multiply by 3 on the numerator and denominator, that will work. And also actually you should multiply by -3, so that's nice. So -3 times -1 is positive 3 times 2/3 is 2, and then -3 times this thing is -2, and then plus 3, which is nothing but 48 plus 3 minus 2 is just 1. So 2 times of 96, which is supposed to be 1812, is 192. So this is supposed to be 0, 1 carried on, you got 4, 1 carried on, so 240. Yep, this is supposed to travel the distance of 240 meters, 240 feet. Alright, before it comes to stop. Okay, the next question is, after striking a floor, a certain ball rebounds 4/5 of the height from it, from which it has fallen. Find the total distance that it travels before coming to rest if it is gently dropped from a height of 120 meters. So it's the same kind of question. So 120 plus, the next time it goes for 2 into 4/5 of 120, then the next time it goes for 2 into 4/5 squared of 120, and it keeps going like that. So this is supposed to be 120 plus 240 into 4/5 plus 4/5 square, all the way like that. And now I will just use a formula which I think most of you already know, the infinite sum of a geometric series which is having a ratio which is less than 1, right? So that is going to be a upon 1 minus r. Here the value of a is 4/5, and this is supposed to be 1. Actually, up till now we have been using the same formula, but we were constantly deriving it, but now I'm getting tired of using that formula with the whole derivation, so just going to use it directly. So 1 minus 4/5, this is 120 plus 240 into 4/5 upon, this is supposed to be 1/5, so this is into 4, which is 120 plus 8, and this is supposed to be 6, so 96, 99, 60, which is 0, 8, okay, 1080. That's nice. Okay, so that's going to be the answer, I think so. And yeah, if I'm making any kind of mistakes, please do tell me, because I'm doing this completely with a fresh mind, and I'm not even like, I'm not seeing these questions beforehand, so I don't know if what I'm doing is actually correct. So if I do make some silly mistakes or something which is questionable, please do tell me. Okay, so the next question is the length, oops, what happened, the length of a side of the square is a meters. So suppose you got a square with side being a meters. A second square is formed by joining the middle points of the square. So these are the midpoints, we just join them. So one thing to notice about this square is that its side length is going to be this length squared plus this length squared, and then the root of that because of Pythagoras theorem. So this new side length, called this s dash, is supposed to be equal to the root of a by 2 squared plus a by 2 squared, which is nothing but 2 times of a by 2 squared, which is a by 2 times root 2, right? The root of that is supposed to be a by 2 times root 2, so that's going to be a upon root 2, I think. So a upon root 2. Okay, cool. And when once again you just inscribe another square in this, then this side length is going to be equal to a by 2, all right, because this is going to be a by root 2 upon root 2, right? This is just similar figures, right? So if the relation between the side length of this original square and this square is that this is 1 by root 2 of this side length, then we can apply the same relation with this and this square. So this side length will also be 1 by root 2 of this side length, and it will keep on going like that. Okay, so what are we supposed to find? We are supposed to find a second square in form of joining the midpoints of the square, then a third square, then a fourth square, and it keeps on going like that. The process is carried on to infinity. I mean, it's carried on forever. Find the sum of the areas of the squares. Okay, so the area of the first square is going to be a squared, obviously. Then the area of the second square is going to be its side squared, which is a by root 2 squared, which is a squared by 2. Then the next is going to be a by 2 squared, which is a squared upon 4. Then the next is going to be a by 2 root 2 squared, which is a squared by 8. So a by 2 root 2 whole squared, and it keeps on going like this. So this is nothing but a square times 1 plus half plus 1/4. Keeps going like this. And I think all of you are aware of this famous geometric progression, that this sums up to 1. Yes, so sorry, this sums up to 2. I mean, this much part sums up to 1, and then this sums to 1, obviously. So this is 2, just 2a squared, like that. Okay, the next thing is, a doctor prescribed an old man to go regularly for a walk. That's nice. He goes for some distance on the first day, but being old, next day he goes half the distance. Similarly, on each day subsequently, he continues but goes only half the distances of previous day. Prove that the total distance moved by him can never exceed twice the distance moved by him on the first day. So suppose the distance moved by him on the first day is x, then on the next day he's going to move x by 2, then on the next day he's going to move for x upon 4, and it keeps on going like this for infinity, all right, which is, now this thing is going to be equal to, as you guys already know, x into 1 plus half plus 1/4, which is 2x, because this thing sums up to 2. If you don't know about this geometric progression and you don't know that it sums up to 2, just use the formula which I gave you, a upon 1 minus r. Here a is 1 and the ratio is half, so this does sum up to 2. You can check it out for yourself. Okay, prove that the total distance moved by him can never exceed twice the distance. Yep, this is proved, because this is going to be when it keeps on going for infinite terms, but we know in reality the man won't live for infinite days. So in that case it's going to stop somewhere, so it's not going to go for the other the other infinite terms. Yeah, the other infinitely small infinite terms, whatever. So you get the idea that there's supposed to be some stuff which is missing, and then he has only jogged or what, go regular for walk. He has only walked for these days, so there's supposed to be a finite limit on how much he can walk. So that is going to be 2x, right? He cannot walk more than 2x. So that's it. That was a nice question. Is there any more question? No, everything is done. So thank you, and I hope you enjoyed it.